Hello everyone. Today we're going to cover about the banked tracks, which is the last topic of the 4-unit math mechanics. Okay, the banked track is sometimes a part of the conical pendulum topic or the angular velocity, etc. But I'll teach you about this topic only today. So a prerequisite of this topic is the conical pendulum. Okay, so you need to know about the angular velocity. Okay, so let's have a look at this one. Okay, we have a great car. Okay, no matter what you have an experience, or when you imagine you drive. Okay, when you imagine you drive, not the straight road, but the kind of curved road. Okay, so how do you think about the curved road? Okay, with the curved road, we usually have a force that I want to get out. Trying to, look, it feels like it tends to get out of the tracks. Did you understand that? This is probably what you are mostly seeing here. Well, also when you're going to the kind of park or somewhere, you are getting into the kind of amusement park, get a ride, a kind of a big round circle, very faster speed. You are feeling something like, okay, I want to get out. Okay, trying to get out of the track. So this is what I'm going to talk about here. Okay, in here, which is the level ground. Okay, so the car is moving towards, but it's make a circular track like this one. See here, that's the radius of R, and approximately around here, this is the center of the track. Do you understand that? So make a kind of circular big track. Say radius maybe 200 meters, maybe 100 kilometers. Okay, so kind of comparably bigger track. Okay, and then what's happening? There are the forces. Okay, here mv squared divided by r. Can you remember this one? Mv squared divided by r is the kind of angular force. Okay, so when you move over here, the force is that I want to get out. Okay, and do you also remember about the tension that I want to get in? Okay, so don't get out. Okay, that there are tensions. So the previous section we learned about the tension and the force that I want to get out. So they are, they are balancing. Okay, so that's why we have a kind of a uniform circular motion. Okay, so it applies to this topic too. Okay, now we have an angular force to in a uniform circular force is going to get out. Okay, it's moving like this one, and then there's also friction force is applying. So friction force is happening where kind of you remember surface of the road is not 100% smooth. It's like a crack. Say like here, whenever road, this is road, but it's not exactly like this. The surface of road will be maybe like that. Okay, it is not completely clean, and then the car wheel moving around here. So there is some kind of friction is happening. Okay, so I want to get out, but these friction forces don't allow to get this car move the other side. So that is friction force. So friction force is always the opposite direction of that angular force. You understand? That's always angular force. Okay, so if this force and this force are balancing together, yeah, then it doesn't go the other side. Okay, but if the friction force is less than what is there, okay, then the car is trying, is having some kind of force, kind of throws to the other side. It's kind of try to get out to the outside. Okay, so that's what we are going to talk about throughout this lesson. Not too hard, guys, so try to follow me. I'll show you the first question to have your understanding better. Question 1, we have a realistic number. Okay, so 200 meters is radius. Okay, so the car is moving to the level ground, right, not a banked ground. And then the weight of the car is 1,000 kilogram. Okay, it's moving on a banked circular track, and radius is 200 meters and 36 kilometers an hour. Okay, so fairly in a slow speed. But what you have to do is, no matter what you do here, kilometers an hour is not usually acceptable in mechanics. Why? Remember that gravity? Gravity is 9.8. What was the unit? ms squared. Okay then. So therefore, the unit of the length must be meters. Okay. So kilometers is not acceptable. So usually we have to change this one to meters per second. So always, mostly always, okay? So, and then find the friction force required to the curve. So friction force, so how do you find the friction force? Which is the balancing force of the angular form, okay? So angular, uniform circular force, okay? So this will be the same amount for this one. So we need to calculate the amount of mv squared divided by r, okay? So first step is to convert to 36 kilometers an hour to meters per second, okay? So how you do? So a kilometer, okay? So 1 kilometer is equivalent to 1,000 meters. And 1 hour is equivalent to 60 minutes times 60 seconds, okay? We need to convert it. So then you will get 10 meters per second. So that's the speed, okay? That's the value for v here, okay? Which is the velocity given here. And then what I like to do is to just calculate it here, okay? So mv squared divided by r. So m is 1,000 kilometers, okay? So this is m, and 10 is the velocity, and r is 200. So substitute everything here, okay? So this is the answer for the question, okay? Grab your calculator, get the simple answer. You have 500 newtons, okay? So not not something like meters or a kilogram something, but newton is the unit of the force. You understand that? So that's question 1A, okay? So the speed was 10 and the friction force was 500 newtons, okay? Now next question is asking us, say any day, say any wet day, you can imagine that, okay, wet day, usually it is slipping, so which means less friction force. So it's easy to slip away. So what happened? Okay, we just measured the degree of the slipness is 20%. Okay, so 500. So usually we have 500 newtons. That's the friction force. So 500 times 0.8 is the maximum friction force in this situation. You understand that? Then we're going to find out optimum velocity, which is car still stay in the same curve, okay, same track. Okay, I don't want to get this car to the other side. So what's happening? This v is not small v over here. This is big V, which is a new v that we are going to find out. Okay, so it's slightly different. And then this was the usual friction force over there. But due to the fact that the weather is wet, so the kind of new friction force, new amount of the friction force is 20% decreased. So we need to multiply 0.8. Okay, so therefore velocity square equals to, so you move mr up there. Okay, so just calculate it. What's r? 200 meters. M is 1,000 kilograms for the vehicle. Substitute in, okay, you can get the value. So velocity square is 80, which is the velocity equals the square root of 80. Okay, so but just be careful. We are working with the meters per second. Okay, so square root of 80 meters per second. But in getting back to the question in answering, okay, then you have to convert it back to the kilometers an hour. Understand that? So we usually talk about the speed of the car is kilometers an hour, so 80 kilometers an hour. We don't normally say 15 meters per second of the car. Okay, so we have to change it to the realistic number, which is multiply 60 times 60 minutes 60 seconds divided by 1,000 meters. Then you will get approximately 32.2 kilometers an hour. So if it's a wet day, so 32 kilometers an hour will be kind of optimum speed, which is north side thrust is happening. You understand that? So that's the situation. So understand that, okay? So firstly, you need to find out normal friction force. So if the 20% is being reduced, take it out and find the velocity. So this is a kind of very traditional style of the question. Okay, so that's part B. Look at part C. Now, getting faster. Okay, the car is getting faster and faster. Okay, but still 36 kilometers an hour. Okay, there must be some particular angle, okay, which makes this car has no friction force at all. So in this case, friction force equals to 0. Okay, so that's what we are going to find out. Okay, then the first step is to find break down the forces with normal reaction, okay, into two forces, vertical and horizontal. Okay, it's vertical and horizontal. The first one, this is N, which is normal reaction. So here, this is theta, okay, and that is theta. So that is also theta. So this force is dismantled by N cos theta. Okay. So what about the horizontal force? It will be N sine theta. Okay. So this N is dismantled by N cos theta, N sine theta. Now, what your view must be at this time, okay, in here, look at this. You have to understand the word of balancing. So balance. What balance is? See here, talk about, consider about the vertical forces only, and talk about horizontal forces only. Okay, see what happened. So look at this one. So what are the vertical forces? N cos theta, this is vertically upward, and mg, which is the weight of the vehicle, is pointing down, but it's still part of the vertical. Okay, so this N cos theta must be equal to mg, which is a balancing. Okay, which will make the balancing. Okay, so that's what you're going to do now, and then the other one equals to the horizontal. So this part and this part, so mv squared divided by r is equal to n sine theta. Okay, and then as I've spoken to you, we're going to talk about the vertical forces like this one. Can you see that? So vertical, okay, so n cos theta should be equal to mg, and then horizontal, mv squared divided by r, which is moving to this direction, and that direction, which is n sine theta, must be equal. Okay, so we just write them. And next step, well, just to be careful. A lot of people, confused about what am I doing? Okay, so what you are doing now is to find out the angle. Okay, so all you need to know is the angle. So n and m, there's a lot of stuff there, but most of them are not necessary for this question. So how to remove them is easy to divide this by that, this by that. Okay, so n will cancel out, and then sine divided by cos will be 10. Okay, so I'm going to show you. So this is what I'm going to divide by that. So this becomes just simply 10 here, and n will disappear. So we can simply write 10 theta is v squared divided by r. That's the algebra. Okay, I'm going to write this one over here. So 10 theta equals to v squared r times g. Okay, right. This theta is the one that we are looking for. Okay, so how you find theta is to find out by the use of inverse tangent. Okay, so sort the values. And then what is v? V equals to 36 kilometers an hour. But remember, we're not going to use the kilometers an hour, but we're going to use the meters per second. So what was the meters per second value for 36 kilometers an hour? Yes, 10. Okay, so that must be 10. What's the radius here? 200. Okay, radius 200. The gravity, which is 9.8. So put those numbers. Okay, so grab your calculator. You'll get the value. It is approximately 3 degrees. Okay, approximately 3 degrees. You understand that? Okay, so this is a process. Say, okay, well, the step 1, 2, 3, 4. This part may be in a kind of independent question. Say something like, hey, in this situation, prove this. It is quite good question already. Okay, so I suggest you to remember this process. From after this point, all you need to do is just substitute the values. Okay, so that is question 1C. So again, what always think about here. Okay, always think about the balancing of the forces. Upward, downward should be equal. Left hand side, right hand side, always equal. So that's basically what you have to understand. Okay. Okay, guys, that was question 1. Okay, so let's move on to the second question. Second question is having, okay, it's slightly different. A car is traveling at constant speed. So it's moving moving toward this direction and make a big circle. And then r, radius of r, okay? So from this point, that's radius of r, okay? So radius of, say, 200 meter something. And then rotor width d, okay? From here to that is d meters. It cares, okay? So the friction force cares about the width of the road, okay? If it's a bigger, it is different situation. So, and that the road slopes at small angle, okay? The angle t towards the center of the curve, okay? You understand it? Well, what's happening? The angle is towards the center. It's like this one. Say what's something not in this case is like this one. It can't be this. This angle, and then it's moving like this. It is impossible. So this is what this statement explains about that. Okay. Now there's no friction force on the wheels of the car, so it is not tending to move upward, not tending to move downward. Okay, so it's a kind of normal situation here. The first question is prove this height is v squared d divided by rg. Okay, how do you do? First step is to utilize this one. Okay, so I'm not going to prove this one again, so I'm going to copy this down from the question one. We're going to use this one. Okay, now in the question, usually have a think about here. In the usual situation of the banked track, this is a realistic question or the realistic theory. So here, how do you think about here? The angle. Well, in this diagram, the angle is quite significantly big, say 30 or 20 degrees Celsius. Oh, sorry, not the Celsius, sorry, degrees. But in reality, it's not this big. It's usually 1 degree, 2 degrees, or 3 degrees. It's a fairly small angle. The stuff, what you have learned in either extension 1 mathematics or 2-unit mathematics, have you ever seen this one before? So tan theta is approximately the same as sine theta when theta is small angle. Okay, if theta is small angle, this is a part of the syllabus or either extension 1 or 2-unit mathematics. So usually, say what's happening in the triangle over here, okay? Say that's opposite, that's hypotenuse, that's adjacent, okay? So tangent theta, how do you write it? Tangent theta equals to O divided by A. And what about sine theta? Sine theta, O divided by H, okay? Now, have a think about here. If this angle is getting smaller, 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 say like this small, then that becomes the opposite. This becomes the hypotenuse. Can you see that? Okay. Say both are having opposite on the top of the fraction. So as angle theta getting smaller, 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 this opposite gets smaller, smaller, smaller as well. So this gets smaller, 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 and this also getting smaller, smaller, smaller. Okay. And then also look at this one. When angle is this much, the hypotenuse and adjacent are quite different. But when angle becomes smaller, smaller, then how do you think about here, guys? Hypotenuse and adjacent getting so close. Okay. Well, I'm not going to say they are same side, but they are very, very similar amount. Do you understand that? When angle becomes smaller, smaller, smaller. Therefore, these two values becomes almost the same. Okay, so if this is say 0.1 degrees, it should be almost the same. Okay, that's what I'm going to say over here. Okay, now in the small angle, okay, then tangent theta is very similar to sine theta. Okay, so this is what I just explained to you guys. And what's the definition of the sine theta? Sine theta equals to h opposite divided by the hypotenuse. So h divided by d. Okay? So tangent theta is v squared divided by rg, which is equivalent to the h divided by d. Just write them. Then write h the subject. Then that's the stuff that we are going to prove. Understand that? Again, guys, you don't have to remember this one, but you need to understand everything starts from this one. Of course, you will need to be able to prove this one separately. Okay, so that's question 2A. Okay, so next part of the question will be asking us to calculate something. Part B. Okay, find H. Okay, so what's the formula? Okay, so firstly, of course, 36 kilometer, and then D is 2. So all you need to do is solve the numbers here. This is the formula. What was the velocity? 10 meters per second, as we found here. And D was 2 meters. Radius is 200 meters. And then G is 9.8. So calculate approximately 0.102 meters. Okay, so the height. And then it's better to write 10.2 centimeters. Okay, so that's what's happening. So in recapping what we just did of this, the first part of the banked track is to see whether you can calculate the angle. Okay, so how you can find the angle. This formula will give you how to find it. Of course, you must be able to prove this one. Okay, so I'm pretty sure you're not gonna getting any confusion from this topic because this is the easy one. A lot of people thinking, oh, hard, banked track is hard. Never. I don't agree with that. It's easy. As long as you can follow me, that should be okay. Okay, guys. I will see you at the next lesson.